Hey everyone, and welcome back to The Explainer. Today, we are cracking the code on something that honestly feels genuinely futuristic. We're talking about an entirely new frontier in artificial intelligence, one that goes way beyond just, talking or answering basic questions. We're going to completely demystify the architecture behind singing AI agents. Think about that for a second. We aren't just talking about generating a static MP3 file here. We're talking about creating a responsive, interactive digital entity that can spontaneously burst into a personalized song completely in real time. It requires a very specific setup, and today I'm giving you the exact blueprint to build one yourself. Here's our literal blueprint for today. We'll start with the anatomy of singing AI. Then we'll be unpacking the tech stack. From there, we'll explore two distinct routes, the fast API path and the DIY open source path. Finally, we'll dive into designing true agent behavior and wrap up with the ultimate AI singing toolkit. Let's just jump right in.
Okay, let's dive into this. Section 1. Anatomy of Singing AI. I absolutely love using the analogy of human anatomy here because it just perfectly describes how these components bring a digital pop star to life. The whole system is basically broken down into three main organs. First, you have the brain. This is your large language model, or LLM. Its job is to think, write the lyrics, and essentially plan out the musical intent. Then we have the voice, which handles the singing voice synthesis. We'll definitely talk more about that in a second, but think of this as the vocal cords of the operation. And finally, you have the orchestrator. This is your central nervous system. It's the crucial glue that manages the timing, the audio streaming, and the user interaction so that the agent actually responds naturally, without those awkward, clunky pauses.
Now, if you take away just one new term from this explainer today, it absolutely has to be this one, SVS, or Singing Voice Synthesis. SVS is the specialized output engine component that actually generates the singing voice. And guys, this is a massive differentiator. A standard voice agent uses TTS, text-to-speech, which is really just designed for a steady, conversational cadence. SVS is built entirely differently. It has to understand pitch, rhythm, sustain, vibrato, and melody. It's the magic that transforms spoken language into an actual musical performance.
All right, moving right along to Section 2, Unpacking the Tech Stack.
So how do these anatomical parts actually communicate? Well, this is the complete voice agent pipeline. It's the journey of a single interaction. It all starts with STT, speech to text. This is how the agent hears you. You speak into your mic, and models like OpenAI's Whisper or DeepGram transcribe your audio into text pretty much instantly. That text is then immediately handed over to the LLM, our brain, which could be GPT-4o or maybe Claude 3.5. The LLM processes your request, so maybe you asked for a song about a sunny day, and it writes those lyrics. Finally, those lyrics get sent to the SVS engine, which synthesizes the singing audio and plays it back to you, hearing, thinking, and singing. And all of this is happening in literal milliseconds.
This really brilliantly highlights the current state of SSVS technology, because we basically have two distinct paradigms right now. First up is text-to-singing. This is the absolute newest method, and it's the one that's really driving this whole conversational AI boom. It generates vocals directly from raw lyrics and text prompts. Models like ElevenLabs V3 or FishSpeech are totally leading the charge here. You just give it words, and it figures out the melody on the fly. Then, on the flip side, we have MIDI to singing. This is the more traditional method. It requires an actual musical score, specifically MIDI notes, alongside the lyrics to tell the AI exactly what pitch to hit and for how long. Models like DipSinger use this approach. So you have a really sharp contrast here. Instant, spontaneous generation versus highly controlled, score-based generation.
So we've hit a fork in the road. Section 3, the fast API path. If you're a developer and you're looking for really rapid prototyping, going with professional APIs is definitely the way to go. The pacing here is incredibly fast. Step 1, you generate the lyrics. The real trick here is your system prompt. You instruct your LLM to act as a songwriter, and this is crucial. You tell it to wrap the lyrics in specific tags, like bracket singing bracket. And you describe the style, something like singing in a soulful pop style. Step 2, you synthesize it. You send that exact text over to the ElevenLabs API, making sure you've selected one of their voice models that's actually optimized with singing capabilities. And then step 3, you stream it. Because instead of waiting for a whole song to render so you can download a file, you use frameworks like LiveKit or Daily.co to stream those audio chunks back to the user instantly.
But maybe you want to get your hands a bit dirty. Section 4, the DIY open source path.
For all the tinkerers and builders out there who want maximum control over things like pitch and vibrato, the highly recommended tool right now is FishSpeech. This is an open source powerhouse for 2025 and 2026. Now, because it's open source, your setup involves hosting the repository locally on your own machine or on a cloud server. But the most exciting part is the cloning. FishSpeech supports state-of-the-art zero-shot voice cloning. Literally, you only need to provide a 15-second reference audio clip of a voice, and the model can immediately sing in that exact voice. For inference, which is the actual generation step, you pass the lyrics using natural language prompts. Inspired by research like Prompt Singer, you can just type out instructions to control the gender, the volume, and the vocal range. And you do all of this without needing any complex musical software.
Just thinking about a conceptual JSON payload for this makes the whole DIY aspect feel incredibly tangible and actionable. You're simply making a local API call right to your own server. You pass the text, tag it with bracket singing bracket, and define a style parameter, like opera. It is astonishingly simple on the front end, while your local GPU is doing all the heavy lifting in the background to render this stunning, operatic AI voice. I do also want to briefly mention DiffSinger as a big part of this open source ecosystem. While FishSpeech is fantastic for text-to-singing, DiffSinger is the tool you want if you're trying to create a full virtual singer, kind of like a custom Vocaloid. It requires a .ds file, which is a combination of lyrics and MIDI. Now, you absolutely wouldn't use this for a real-time conversational agent, but if your goal is to spend hours in a studio crafting a high-quality produced track with manual pitch control, DiffSinger is your absolute best open-source option. So, bringing these two paths back together, let's look at Section 5, Designing True Agent Behavior.
This brings us to a massive question, and honestly, it's the one that defines the success of your entire project. How do we make it an agent, and not just a media player? A media player just passively plays back a file, right? An agent needs to have context. It needs emotional intelligence. It needs to react to you, the user, in real time.
So, how do we bridge the gap between static code and dynamic personality? Well, here are the advanced strategies. First, melody prompts. You literally program your LLM to analyze the user's mood. So if the user sounds happy, the LLM autonomously generates style tags, appending commands like bracket upbeat, high pitch, bracket, to the synthesis request. Second, we use latent space control. With models that are heavily influenced by the Prompt Singer research, you can actually specify pitch changes, like +2 or set the volume to soft, directly within the text string itself. And finally, orchestration. This is where the magic really happens. By using the LiveKit Agents Python SDK, you handle those complex WebRTC connections effortlessly. This lets your agent actively listen to a user's microphone, hear a request like, "Sing me a happy birthday song," and respond instantly with a generated, emotionally appropriate audio stream. That is what true agent behavior looks like.
Which brings us to our wrap-up, Section 6, the AI Singing Toolkit.
This toolkit right here is your ultimate screenshot-worthy takeaway. Let's do a quick recap of your options. If you want an API for rapid prototyping and amazing zero-shot singing, you're going to use ElevenLabs v3. If you want open-source local hosting with high-quality voice cloning, you deploy FishSpeech v1.5. Now, if you are stepping completely out of the agent space and into professional music production that requires strict manual control, Synthesizer V is your software of choice. If you want to transform an existing spoken audio file into a singing file, basically voice-to-voice, you should look at the open-source Sovitz SVC. And finally, for cutting-edge control of vocal nuances using just text prompts, you're going to look toward the research and open-source models built around Prompt Singer. Whatever your specific goal is, your tool is on this list.
To close out this explainer, I want to leave you with something provocative to chew on. What actually happens to music creation, to entertainment, and just to our daily tech interactions when your conversational AI spontaneously breaks into a personalized, real-time song? We're no longer just passively interacting with machines, we are collaborating with them creatively in real time. The blueprint is in your hands now. It's totally up to you to decide what kind of voice you're going to bring into the world. Thanks so much for joining me on this deep dive, and I will see you on the next explainer.